All right, so today I'm going to be doing a quick demo on the OMIGOD vulnerability. And before that, I sort of want to talk about quickly about burnout and work in our industry, right? So last week was when I started doing these kind of videos again, these tech demos. But before that, there's this 2 month gap where I didn't do anything. And basically what happened was that earlier this year, I was doing so much personal development with my tech stuff, and I was really enjoying it. But I think I was just doing too much, and just like with personal responsibility and work, I got burnt out. So I had to take this nice long break and not do cybersecurity stuff in my free time. And that was good, and I recuperated. And now last week and this week, I'm sort of energized and I'm ready to go. So I just want to share that with the audience to know that burnt out is a real thing, and make sure to take care of yourself, right? So today I'm going to talk about this OMIGOD vulnerability that's been sort of pretty hot in the news, right? And basically this wiki here by Wiz.io basically, yeah, go through it in detail. And today the way I'm going to be sharing it is a very script kiddie way. So basically, in this way, you're a researcher, you're sort of a cybersecurity person, but you don't have that much time to actually spend a lot of time reading, understanding, and researching it. So you just saw this article and you're like, hey, I really need to patch this, or see if my systems are vulnerable in that, right? So that is when you might take a script kiddie approach. And that's okay in terms of you don't have that much time and so forth. You have to just check the vulnerability. And so that's what I'm doing in this particular session. In a future session, I'm hoping to have more time to sort of really dig into this article to really understand what's going on. And then that's sort of a more deep understanding of this actual vulnerability, right? And then in that case, I would be better able to understand the risks and understand, according to different contexts, how I want to perhaps mitigate and do different type of security controls depending on my needs, right? So let's start. So the exploit itself is from this Git repo right here. So in my quick environment right here, I set it up on this Ubuntu box right here. And so this is a target machine. It's going to be running on Ubuntu. And my attack machine is this Kali Linux. So first off, I have to get the IP address of the target machine. So it's 192.168.237.129. So 237.129. So back to my Ubuntu box, Python 3, OMG, and let's really quick, 237.127. 237.129. Okay. 237.129. Okay, cool. Oh yeah, and then 192.168. And I'm just going to run this incorrectly first, just so I get an error message, right? So first off, the first step we should do is we should probably look at the exploit itself, right? So it's like, okay, it's a Python 3 script. It looks like there's this data variable, right, with some arguments, and then finally you get this exploit function that's creating a this header, and then it's sending the requests. So that's what the exploit looks like in a nutshell. And again, right now I'm showing it from a script kiddie sort of level, right? So we're not digging in too much details of how it actually works. And if you run it incorrectly or just run it without arguments, it tells you how it works, right? So it says you run the Python script, and T for the target, and C for the actual command, right? So now let's run it with the correct argument, Python 3, oh my God, target 192.168.237.129. Oops, 129. And my command would be, ID command, right? So I run it, and lo and behold, it looks like it works, right? So I get the results of the ID command, which is root. So that's awesome. But let's do something a little more interesting. So rather than just ID, I'm also going to run the IF command as well. So ID, semicolon, and then the next command following that. And I put that all in parentheses, right? I run it, and yeah, so I get the results of the ID command, and I also get right the IP address from running the IF config. So great. So this works. So, okay, so now let's talk about the CyberForce competition itself, right? So for the CyberForce competition, according to what I understand of this exploit, we're probably not going to run this for the CyberForce competition. I think because the big reason is probably the term of service for the actual infrastructure provider that we're using, right, is probably not allowed, and also probably our scope, the narrative that we're using for the red team for the CyberForce competition, it probably doesn't include this attack surface. So that's why we're probably not going to use this exact exploit, but we might potentially, if we were going to do something like this, we would probably create something that's representative of it, right? So basically, let's jump back really quick to the article here. And so the little bit that I kind of gleaned from it is basically there's some issue about the authentication header, and basically if you could put something bad with something that's nonsensical, it doesn't really check it, and then it'll still execute your command. That's right now, according to my script key understanding of how it works, that's what's happening, right? So potentially, if we were to implement something like this in the CyberForce competition, we might implement that kind of vulnerability in something that's representative. And in terms of scoring the blue team, so in the CyberForce competition since last year, we do not dock points as a red team. The red team can only give you points. So basically, we have to come up with a scenario to test one of your blue teaming skills. So in this case, it might be detection, right? So we might run this exploit, and then, excuse me, for the actual scoring part, we'll ask the blue team, are you able to detect it? Or where in the log files does that show up that whether or not this attack works? And can you get any information about the attacker himself according to whatever kind of forensics or visibility tooling that you have in your environment, or your understanding of how the logging works with that vulnerable service. So right now, according to my quick playing with this exploit and sort of our goals for the CyberForce competition, that's what I imagine it looking like, right? So now let's sort of take it up a notch. And how we're gonna take it up a notch in this particular case is, I think my Kali VM would be best here to play around with this, right? So let's go here, open VPN. So now we're jumping into, we're gonna jump into an actual, our current test VM within the actual environment. So that's what we're doing here. So let's see, CFC. Geez, let's open VPN. So, I'm connecting to the VPN, hopefully. All right, that's going. Right, great. So I'm connected. And let's jump to the box here, grab blue team. All right, great. So we're gonna SSH into one of our boxes here. Okay, so now we're on the box, and these VMs are running in the Azure environment. So my question to you guys, the audience, right, that are here, is that how can we check whether this vulnerability is applicable to us, right? So we read the article, we're like, oh my God, there's this horrible OMI vulnerability, and it's on Azure. We have a VM on Azure. Is it applicable to our VMs?
Yeah, is there a way to check the version of the OMI agent?
That's really good. Yeah. So number one is checking the version, but then let's even take one step back before the version. Is like, before we even ask if what version it is, what should we be asking?
I don't know the exact question, but the OMI service is applicable to an agent that runs on the system. And for this R remote code execution, it is only applicable to things like the Azure Analytics service, which requires that port to be exposed outside of the VM. Otherwise, according to the article, these are all local privilege escalations that can occur once access is achieved on the box.
Yeah, let's so the 2 points that you brought up, Dave, that is sort of what my question is sort of getting at is it even on there? is the agent even on there? That's number one. So let's test that out, right? So we run a, oh, come on. Okay, cool. The VPN is kind of bad, but okay, so OMI, right? So if we do this on the actual, if we do this on our VM, look, check it out, right? It's not there. So that's number one. It's like, oh, okay, you know, relief. The agent isn't even running. So let's go back to my actual VM that I created in my own instance, right? This is what it would look like if OMI was actually running on your system, right? You would have these values. So that's number one. Number one is if the OMI is actually running, the agent's actually running there. And in our case, it's not running. And then the second thing you mentioned, Dave, is the ports. That's another really a good way of seeing, like, am I affected? Does this apply to me, right? So in our case, if we run netstat really quick right here, right? Come on, netstat, you can do it. Yeah, let's check our, okay, cool, it came back, right? So we run netstat, check it out, right? So the ports that this agent is running on is a 5986, or one of these options. So we, according to these two checks that we're doing, against our VM, the agent isn't running. The port that's associated with that agent, if it was running, is not there, right? So that's two. And then Jesse was right on in terms of if the agent was running, what version is it, and therefore is that version that we're running vulnerable or not, right? So because okay, this grab OMI. Okay, so this is my own on my own VM, obviously, right? It's 1.6.80, which is a vulnerable version. But because on our Azure VM itself, the OMI agent's not there, so obviously there's no version. But so that would be how you would check for that. And for students competing, this process that I just went through, that's very important. When you get news, you're reading some articles, you're like, oh, there's a scary vulnerability, then you have to see if it's really applicable for your system, and that's how you can go about checking for it. I think that's it in terms of what I had for this demonstration. So let's